This is one of a series of 7 videos about the different strands in the AS and A-level OCR Further Maths B MEI specifications. This one's about the mechanics strand, and we'll look at some questions from both the AS and A-level papers. Do take advantage of the fact that you're watching a video. There's a lot to take in, so keep pausing and reflecting. You might consider whether you want to engage with this video over 2 or 3 sessions. Make sure you have the handout that goes with the video. It has some candidate scripts for you to try marking. This goes with section 5, and it's a good idea to try marking the questions before you watch that section of the video. The handout also has some other information which will be referred to throughout the recording. It sometimes helps to take a break from the screen and read some printed material. The meat of the video is in sections 4 and 5. In section 4, we look at some exam questions and the schemes to illustrate what examiners mean when they use words like show that or find. In section 5, you try some marking, and we look at how the assessors mark those scripts in the video. Hello, I'm Keith. I work for MEI, and one of my jobs is to support teachers of the MEI, AS and A-levels in maths and further maths. I was a maths teacher for 25 years. I worked for OCR for 5 years, and now I work for MEI. While working for MEI, I helped to develop and design the current A-levels, the MEI A-levels in maths and further maths. And now I support teachers who teach those qualifications. Do get in touch if you have any questions or you want any support. I'm here to help you. So we'll look first at the structure of the AS and the A-level and how mechanics fits into that structure. First of all, we should say that the content matches in a sensible way. There's an AS paper in mechanics, and that matches the content of the A-level minor paper. The A-level major paper includes that minor content within it. The structure for AS further maths is straightforward. You sit 3 papers, one of which is compulsory, the core pure paper, and then you have 2 optional papers, and mechanics can be one of those options. The A-level structure is slightly more complicated to allow maximum flexibility for schools and colleges and students. There's a compulsory paper, a core pure paper, that's worth 50% of the marks. And then you can take mechanics in one of 2 ways within A-level further maths. You can take it as a major option worth 1/3 of the A-level, and then you'd have to choose a minor option to go with it, not mechanics, but any of the others go with that. Or you can choose mechanics as a minor option worth 1/6 of the A-level, and then alongside that you can either choose statistics major or 2 other minor options. There are more details on the handout as well as in the specification itself. But there's lots of flexibility, lots of ways in which students can take some mechanics in A-level further maths. The content of the minor option, as I've said already, is the same as the content of the AS mechanics paper and is designed to be co-teachable in Year 12 alongside the first half of A-level maths or AS maths. A reminder first that there are plenty of practice papers or past papers that can be used to help with your students. Some of them are only available on Interchange, OCR's secure website, for which you need a password, which your exams officer can provide for you. And some of them are available on the public-facing OCR website. Notice that only one series of papers, the summer 2019 papers, has been sat by a reasonable sized cohort of candidates. The 2020 and 2021 papers, which were designed to be sat in the summer of those years, well, as you know, the series was cancelled. The papers were made available for the autumn, but not many candidates sat those papers. And that has some consequences for you in using these papers as practice papers. The first is that the mark scheme may not be as detailed as the summer 2019 papers. So the practice papers, the mark scheme was written as the question papers were written, but the examiners have not had any feedback on those papers. For live exams, the senior team of assessors, the principal examiner and the team leaders look at several scripts, lots of scripts, over 100 scripts, and they adjust the mark scheme to take into account different methods that students, candidates might have used in sitting the papers. Clearly that's not available for the practice papers, and there wasn't much that they could do with the mark schemes for the 2020 and 2021 papers because they didn't have many candidate scripts to look at. So the summer 2019 mark schemes will be the most detailed. The other issue is that the thresholds for 2020 and 2021 were set so as to be in line with, so as to produce results in line with the center assessed grades that were produced in the summer of those 2 years. And that means they're slightly more generous than the 2019 outcomes. So there are plenty of papers, plenty of questions, but you need to be a little cautious about the mark schemes and the thresholds for those papers. We'll think now about the command words, the words that examiners use, that candidates and the teachers need to know about to see what's expected of them. OCR produces a useful poster on their website, which you can print out and display in your classroom, of what those words mean. And we'll have a look at some of them with examples in this section of the video. I particularly want to just point out right now the word determine in the bottom right-hand side that expects some justification to be given and some working as appropriate. So here's the question with that statement in bold. In this question, you must show detailed reasoning. And you'll see that phrase coming up, that instruction coming up in several places, in several papers across the maths and further maths specification. And it has a particular meaning, which is outlined in the spec and also on that poster that we've just looked at. And it means that students do have to show line by line how they achieved their result. And just giving an answer or giving a sketchy method may not attract full marks. So this question is worth 9 marks. And we're not going to be just quoting formulae that we might happen to know for centers of mass or for particular centers of mass. We're going to show our working. So here's the mark scheme. This is the minimum that the examiners require to get the marks. You might encourage your students, you notice the very first mark there, you might encourage your students to show how they get root 2 over 2, to actually work through the integral for the area. And not only is that something that's guaranteeing that they get the marks, they're going to have to think about whether that integral of sine is cos or negative cos, and that warm up thinking will stand them in good stead for the rest of the question, might help them not make a slip in the remainder of the question. So this question is clearly assessing whether students can use their integration techniques, as well as knowing how to calculate a center of mass. And we notice that the core pure techniques are coming into play here in doing the integrating. I just point you to the final answer, which gets that final accuracy mark. There is an expectation in these specifications since 2017. It's explicitly written in the specification that candidates are expected to simplify their answers without necessarily being told to. So looking at this expression for y bar here, the y coordinate of the center of mass, that is clearly not a simplified answer. And if you gave that in your coordinates for the final answer, you may well have a mark deducted. Now, this question comes from a practice set, so the mark scheme is not as detailed as it would have been if it had been sat by candidates, and the examiners, the senior team, would have had to decide whether they would accept an unsimplified answer in the final line. It's within their rights not to, given what I've said about what the specification says. But you'd certainly expect, wouldn't you? I think you'd hope that your students would simplify the top line and remove as well, the spec makes this clear, remove as well the irrational value from the denominator. Actually, I'm not confident that the examiner has simplified this first, the x coordinate correctly, hit that root 2 over 2 term, but I'll leave you to just have a closer look at that. So here's an example of a question where it says determine. And as we've pointed out, we're looking for a clear justification. And we'll see how that plays out in the mark scheme. We're not just looking for the calculations, we're looking for some sense that the candidate has a strategy and knows what they're doing. And it doesn't take much to show that, but there's a logic to what's happening here, and it shows up really in the last mark. So we've worked out the kind of the critical values for P, if it were to slide or if it were to topple. But in get to be awarded that last accuracy mark, we need to explicitly compare them and to give an answer. So that's part of the force of the word determine in this question. A show that question here. We won't look at the scheme, but just to point out that the examiner does need to be able to make sense of the reasoning that the candidate engages in. Verify, we'll look at the scheme for this in a moment. Verify is a command word that candidates should be familiar with. They come across it in pure questions as well. We've got ourselves a differential equation in part 1, and we're not being asked to solve the differential equation. The marks for part 2 are available even if a student can't successfully achieve part 1, because the answer is given in part 1. So you can tackle part 2 even if you can't do part 1. And verify, as I say, we're not needing to solve the differential equation, we're needing to show clearly that the solution given satisfies both the differential equation and the boundary condition. After 1 minute, the velocity is 33. So here is the scheme for this, and just focusing on the on part 2. You can see that the scheme starts with the boundary condition. Doesn't have to, doesn't matter which way around the candidates do this. And one of the method marks is dependent on the other one. Here's an example of a question with the use of the command word find. And although that does technically mean that a correct answer would be sufficient, the scheme will have method marks. And those method marks can only be awarded, they're there for the candidate who doesn't get the correct answer, so that the examiner can give some partial credit. But of course, if those methods are not shown, then that partial credit can't be obtained. Notice the comment about good practice when using a calculator. So this type of question, part 2 here, sometimes asked about modeling, a comment on the modeling, a comment on the model, or a suggestion for how the model could be improved. There will always be something like that in one of the questions in the paper. And it's important that we don't just offer a vague answer to this question. Put it in the context of the question. And the scheme shows how that can be done. We've commented already about how when you use a calculator to do a calculation, it's worth writing down what the calculation is that you've done. It's perfectly fine to use an equation solver or numerical calculus from your calculator, unless, of course, the question is asking for an exact answer or is a detailed reasoning question, in which case you should set out how you solve an equation or how you perform an integral, find the value of an integral. It might be worth pointing out here that you can find online some good computer simulations for different mechanics concepts using GeoGebra. If you go to the GeoGebra website, you can search it and find some great simulations for different mechanics scenarios. Now we're going to come to the marking exercise. It might be that you've looked at some of the other videos in this series and you've seen some advice about some general advice about how marking works, and that applies to these papers as well. But if you have a look at the handout now, you'll see a few questions with their mark schemes and then some candidate scripts. And it really would be worth your while pausing the video and having a go at marking those scripts for yourself. You might find it quite informative in how you teach your students to approach exams. So pause the video. How the assessors actually mark those scripts is what's coming up in the video now. So let's have a look at that. Quickly, just to put them in context, you'll have seen this question paper, this question. We're finding the y coordinate of a center of mass of a solid of revolution. And here's the scheme, which you'll have used in marking the scripts. And here's the first script. How did you get on in marking that? The candidate makes a good start, but unfortunately they lose a third when integrating by parts. And you can see where the examiner has highlighted that. In fact, they lose the third in the line above, but that might have been a slip. They might recover. This is the point where the mark is awarded or not. So they lose one of the accuracy marks. They then pick up the next method mark, that's fine, but the final accuracy mark is lost as well. It does require some careful reading, doesn't it, to spot that. Though, of course, you know from the final answer that something's gone wrong somewhere. Here's another script on the same question, but it's hard to give this candidate any marks at all. They're just not performing the right solid of revolution in their head. So this script is an interesting one. It's hard to give marks, but actually there is one mark available, and it does require the assessor to read through line by line. You might think by the time you've not given those first 3 marks that nothing's going to go right, but actually look at the method mark, the second method mark in the scheme. So we don't have integral of y x squared dy. The examiner's highlighted where that is not there, and that's not there in the actual integral that the candidate's integrating. They haven't squared e to the 3y over 2. But they have got an x in that integral as well, but they haven't quite followed through what they're trying to do. So it's not clear that they mean that x to be in the script just at this point here. But if you notice where the examiner's given a method mark, there is that in the right-hand column of the guidance. There's a clear indication of integrating exponential term and differentiating the y term. So clearly the assessors read this really carefully, looked carefully at the scheme, and is happy to award that method mark. Nothing else earns credit. So a question about a car going up an inclined slope. And a scheme. Now, it's worth pointing out here that there isn't a diagram in the question and there isn't a diagram in the mark scheme. In other words, the mark scheme is not producing a perfect solution or an ideal solution. Perhaps perfect is too strong a word. And you would want your students, I'm sure, to draw a diagram for this question. So be careful about setting up the mark scheme as being an ideal solution. It's not meant to be that. The mark scheme is trying to show assessors and teachers how credit can be given for an answer, for a solution which isn't ideal. How is partial credit awarded? So don't give your students the impression that because the mark scheme doesn't have many diagrams, they don't need to draw diagrams in their solution. So watch out for that. Let's have a look at the candidate scripts then and see how you got on. And one of the features of marking mechanics papers, you'll know this perhaps if you've done any marking, is that candidates don't get the marks in the order that they appear in the mark scheme. And sometimes you have to look quite carefully to award even one of the early marks. So it can be quite challenging to do that. So the first mark in the scheme, the work done by the car, is actually the third mark on the script, that B1, and that's fine. The second mark in the scheme is the 98,250, is the second mark here. But actually the B0 that appears first on the script is the third mark in the scheme, the change in potential energy, and that's the mark that the candidates lost. They've got a distance there, a height, a vertical distance, 131 times sine 5, but they've not used the weight, the 800G, to find a change in potential energy. So that mark is lost. Now look at where the examiner has produced a couple of highlights here. So this equation is not entirely correct. Of course, we know the 131 sine 5 is wrong. But of course, we're trying to get a method mark here, and we know that that's what the candidate thinks is the change in potential energy. So that's not going to rule out the method mark here. We're looking for the use of the work energy principle. All terms present. Well, yes, we have got all the terms present. Values substituted. Well, yes, we have got values substituted. V, of course, is what we're trying to find. but we've got a sign error here. And if you look in the right-hand columns, a sign error is allowed as long as we have a difference in kinetic energy, a change in kinetic energy. So the examiners highlighted two things here. One, the sign error, and two, the fact that they have got a change in kinetic energy, a subtraction there. So not all sign errors are permitted, but this one is okay. So the examiners looked at that carefully and has given the M1 mark there, the B1 for the change in kinetic energy, and then the M1 for this work energy principle. Of course, the last accuracy mark is not obtained. There have been two slips in the script. This candidate uses the alternative method, and that line is correct. I'm sorry, sorry, I misspoke there. The method is fine. Of course, it's going to be hard to work out that integral, and maybe you might get some marks for a numerical value, but this candidate's not got the first line right. They've got a right idea, but they need to get this integral right. It might be that with more candidates attempting this method, there might have been a scheme developed for interim marks here. This candidate, we can't help being human. We look at the answer first, and they've got the correct answer, and they've got it to 3 significant figures. So that gives us a lot of hope. But we must go back and check here, and the assessor has done that and has carefully shown where the different marks are awarded. And indeed, this is a good solution. So a center of mass question, but a little bit of thinking to do. The center of mass of this object could be outside the shape itself, the lamina R, by being in the top left-hand corner, above P and left of Q. So the students need to have that kind of logic, as well as just doing the standard work on finding where the center of mass is. And you can get credit for just working through how to find a center of mass, even if you're not quite confident about the logic of the question. And the scheme shows that. So there are marks there. There are a couple of marks for working out the center of mass, or the coordinates of the center of mass. And then there's a mark for the principle of what you're trying to find, where the center of mass might be, what conditions we would want to satisfy for it to be outside of R. And then there are marks for the solution. And a final mark for realizing that the two constraints can be summed up in one constraint. So let's look at the candidate scripts. Now, I mentioned before that candidates often get awarded marks in a different order from the scheme, or their work has to be considered in a different order from the scheme, and that's the case here. So the candidate's using vector notation, which is absolutely fine for this kind of question, whereas the scheme considers x and y coordinates separately. So the M1 that the examiner has awarded here is actually the first mark on the scheme and the fourth mark on the scheme. Then the candidate has looked at the X coordinate, and the M1 that we're getting at this line here is actually the second method mark in the scheme, and they've successfully got to K greater than 1 there. They've not done any work on the Y coordinate, so they're not going to get the remaining marks. So here is a complete solution, but there is still some thinking to do. As we work through the scheme. So everything is proceeding well. Perhaps the second method mark might be awarded a bit lower down when they start looking at some inequalities. But the interesting feature about this candidate is that they haven't quite got their mechanics thinking hats on, have they? If we look at this part of their solution here, they're actually thinking that there are different ways in which the center of mass can be outside the lamina. They're thinking it might be to the right of Q, or they're thinking that it might be, well, as the correct answer. They're also thinking it might be above Q. That's what's happening here. They've got three ways in which the center of mass can be outside of R. And of course, it's their third method that is the actual one that makes sense. So they're really not thinking good mechanics. How could the center of mass possibly be to the right of Q for this shape? How could it possibly be above Q? That's just not feasible. So you might wonder, should we consider this script and say, well, let's just ignore that thinking? Or should we say, actually, there's some bad logic in what the candidate has done here? The question says determine, so the logic of what they're doing matters. Is there a case here for not awarding some marks? Well, the mark scheme is thin. It doesn't suggest what ought to be done here. But you'd hope at least, I think, that an assessor would contact their team leader to seek some advice about this. Because the candidate does end up with some nonsense here. K is less than -3. And the assessor has just ignored that other working, has found the correct working, method 3 here, or condition 3, and has looked at this and said, well, they've summed that up to mean K is greater than 3. But they have got this possibility from this first scenario, which of course doesn't make any sense in this question. So, generously marked to get full marks, and you'd hope that the assessor consulted their team leader. You also might hope that the scheme actually said a little bit more about that than it actually does. this candidate here, again, this needs a bit of careful reading, and we've actually got an algebra slip where which the assessor has noticed. But this doesn't rule out the awarding of many of the subsequent marks. They've made a slip in calculating the center of mass of the x coordinate, so they're not going to get that inequality right here, but they do get the method mark right there. They do get that method mark there. So they've got two inequalities, and they have followed through to combine them into one inequality, so they've done well there. But the scheme is clear that you can only get this final accuracy mark if you've got all the other marks up to that point. You could have imagined an alternative version of the scheme where the candidate only lost 1 mark for this solution, but of course assessors stick to the scheme as it's given. So that's the end of the marking exercise. Go on to the, just to mention a couple of other things, there are plenty of resources available to help in teaching and learning of mechanics, and here are a few of them. The OCR website has plenty of support, and you can find out resources find resources there as well as support. The Advanced Maths Support Program, the AMSP, provides professional development and support for teachers of all specifications, including this one. Registering for the AMSP gets you some access to Integral, which is a website of resources run by MEI. There's also a subscription model where you can pay for access to Integral, and that gives you student logins, so you can keep track, for example, of how students do on assessments. And there are also resources on the MEI website as well, freely available. This is part of a series of recorded CPD events, and OCR regularly runs CPD for teachers of this specification. Keep an eye open for that. And finally, you can always get help from a person. There's a maths team at OCR who support teachers, and there are their contact details. And you are also welcome to contact me for any support that you need, whether it's professional development or some resources or some advice. Do contact either the OCR maths team or myself. Thank you for watching the video. I hope it's been helpful, and hope to meet you someday in one of these sessions.